This is section 2-3, Graphing Linear Functions, 2-3b, and we're looking at the second half of the objective for this section, which is I need you to be able to graph linear functions. Today you're going to graph linear functions using intercepts, which represent 2 points. So let's take this objective and turn it into your essential question. Now, something for us to remember first from Algebra 1, and that is what the definition of a y-intercept and an x-intercept is. It says a y-intercept is the y-coordinate of a point where the line crosses the y-axis. Remember, the y-axis is the vertical axis, so the y-intercept is where the red line, in this case, crosses that y-axis. It would be at y equals 2. The x-intercept is the x-coordinate of a point where the line crosses the x-axis. So again, the x-axis is the horizontal axis, so the x-intercept would be where the red line crosses that horizontal axis. Again, here it would be x equals 2. We're going to use these two pieces of information to help us solve problems. Now, what we need to remember are the coordinates at each of these intercepts. At the y-intercept, the value of x is always 0. So the y-intercept in this picture is at 0, 2. At the x-intercept, the y value is always 0. So the x-intercept in this example is at 2, 0. So I need to remember, at the y-intercept, x equals 0, and at the x-intercept, y equals 0. You're going to use that fact to solve some problems. Okay, here is example 3, graphing lines using intercepts. I want you to find the intercepts of 2x minus 3y equals 12. We're going to start with the y-intercept. Remember, at the y-intercept, x is equal to 0. So if we plug 0 in for x, we get 2 times 0 minus 3y equals 12. 2 times 0 is 0, so we have minus 3y equals 12. Divide both sides by negative 3, we get y equals negative 4. So that means that the y-intercept is at 0, negative 4. I'll put a dot there, 0, negative 4. And now we're going to find the x-intercept. Now remember, at the x-intercept, y is 0. So we'll take the same equation, but this time we plug in 0 for y. So we get 2x minus 3 times 0 equals 12. And 3 times 0 is 0, so 2x equals 12. Divide both sides by 2, we get x equals 6. So that means the x-intercept is at 6, 0. Remember, y is 0, or x is 0 at the y-intercept, y is 0 at the x-intercept. So let's put a dot at 6, 0. And so we have found both intercepts. 0, negative 4 is our y-intercept, 6, 0 is our x-intercept. And the last part of the problem says graph the line. So to graph this line, we simply connect the dots. So we draw a straight edge from the y-intercept to the x-intercept, and we have our graph. Remember, the y-intercept is at 0, negative 4, and our x-intercept is at 6, 0. And then that's the line between the two. Okay, so here's an example for you to try. Write it out on your paper, and then start the tape when you're ready to find the answer. Here we go. We're going to find the y-intercept first. And you know the order doesn't matter. You can find the x-intercept or y-intercept. But for the y-intercept, remember, x is equal to 0. So we plug in 0 for x. We get 6 times 0 minus 2y equals negative 24. Solving that for x, or for y, we get minus 2y equals minus 24. Dividing both sides by negative 2, y equals 12. So that means the y-intercept is at 0, 12. And now we find the x-intercept. So for the x-intercept, we know that y is equal to 0. So if we plug y equals 0 into this equation, we get 6x minus 0 equals negative 24. I skipped a step there, so I hope I didn't lose you. Divide both sides by 6, and we get x is equal to negative 4. So the x-intercept is at negative 4, 0. Let's plot those 2 points. And I notice my graph is too small, so I have to improvise a little bit. The y-intercept is going to be at 0, positive 12, which is going to be way up at the top of the screen, way up here. We got 6, 7, 8, 9, 10, 11, 12. And then the x-intercept is at negative 4, 0. And then to sketch the graph, we simply draw a straight line between the two, put in some arrows, and there's our answer. there's the graph of the line, 6x minus 2y equals negative 24. Now, here's example 4. I want you to be able to graph functions in slope-intercept form. So in this equation, or in this example, they're going to give you an equation, and they're going to want you to first write it in slope-intercept form, and then sketch the graph. Now, I need to remind you from Algebra 1 that slope-intercept form is y equals mx plus b. Remember, the m stands for the slope, and the b always stands for the y-intercept. So if I give you an equation in this form, you can very easily graph it. Now here's example A. We have 3x plus y equals 5. Not quite y-intercept form or slope-intercept form because the y is not all by itself. But we can use a little algebra to very easily do that. We need to just subtract 3x from both sides. And the 3x's cancel on the left. We're left with y equals. And to write it in mx plus b form, we would write minus 3x first, and then plus 5. So now we know that our slope is negative 3, or writing it as a fraction, negative 3 over 1, and our y-intercept is 5. So to graph this, you always start with the y-intercept. You put a dot on the y-axis wherever the y-intercept is located. In this case, the y-intercept is 5. So I put a dot at y equals 5. Then I'm going to use my slope to find my next point. This slope, remember, is rise divided by the run. So in this case, rise over run is negative 3 over 1, which means it's going to go down 3 and over 1. So the next point on the graph has to be at 1, 2, down 3 and over 1. So then just connecting those 2 points, and then you've got your graph. So the steps again, make sure you write it in slope-intercept form first, y equals mx plus b. So use a little algebra to manipulate the equation if you need to. From that, you can find your slope and your y-intercept. Graph the y-intercept first. We always graph the y-intercept first. It's always graphed on the y-axis. And then use your slope to find your next point and connect the dots in a line. So here's our final example in this section, 2-3b. And in this one, we want to do the same thing. We want to write it in function of slope-intercept form and then graph the function. So that means we've got to take this equation, 3 over 2y equals x minus 3, and write it in y equals mx plus b form. It means we need to get y all by itself. To do that, we've got to get rid of that 3 over 2. So to get rid of something that's being multiplied, you usually divide. But when it's a fraction, there's a little trick that you should remember from Algebra 1 that makes it go away a lot faster. All we have to do is take that equation and multiply both sides by the reciprocal. So since we had 3 over 2y, we want to multiply it by 2 over 3. And then algebra says whatever we do to one side, we have to do exactly the same thing to the other side. So the other side needs to be multiplied by 2 over 3 also. And then what's nice is on the left-hand side, the 2 over 3 cancels. You're left with y, like we like. And on the right-hand side, we simply distribute. So we get y equals 2 over 3x minus 6 over 3. 2 times 3 is 6. 3 times 1 is 3. Okay, and then that can reduce. Y equals 2 over 3 times x minus 2. So now we have our slope and our y-intercept. The slope is 2 over 3, and the y-intercept is negative 2. So remember from the last example, what do we write, or what do we plot first? The y-intercept. So we put a dot at y equals negative 2. And then use your slope to find the next point. 2 over 3, rise over run, means we go up 2 and over 3. Up 2 and over 3. 2 over 3. And then to graph the function, we simply connect the dots and make our line. So the function in slope-intercept form, y equals 2 over 3x minus 2. In the graph, we plot the y-intercept first, use the slope to find the next point, connect the dots.